Alright, welcome to Algebra 1 Review Week, Part 1. For the first part, I'm going to talk about some definitions from last chapter. My name is Mr. Kennedy, and we're going to begin. So, first definition is monomial. And mono means one. So a monomial is an expression with only one thing in it, like x or like 6. Those are both monomials. If you have a binomial, you have two terms. So a binomial is like x plus 2 or x squared minus 4. Those are binomials. A trinomial has 3 terms. Tri means 3. And so we have x squared plus 4x plus 4. That would be a trinomial. And there are more nomials, but after that we kind of call everything, and binomials are included within this, a polynomial. Poly just means more than one number in your expression, or more than one thing in your expression. So everything that isn't a monomial is a polynomial. So this is the big overarching term. Those are our first 4 are nomials. So again, monomials 1, binomials 2, trinomials 3, and polynomial is anything bigger than 1, term-wise. Our next set of terms is linear, quadratic, and cubic. This is also a 1, 2, and 3. For linear functions, we always have just a single x. X is not raised to an exponent, so like x plus 4 is linear. For quadratics, we always have the biggest power be a power of 2. So x squared would be a quadratic, but x squared minus 7x plus 12 is also a quadratic because its biggest power is 2. And then cubic would just be biggest power is 3. So x cubed plus x squared would be cubic even though it has an x squared in it because the biggest power is 3. All right. Our last definitions are the order or power of a function. If it asks for the order or power of something and they give you something like x cubed plus x to the 4th minus x, all you do is you look for the biggest power in the problem. And the biggest power in this problem is x to the 4th. So this would be an order or power of 4 function. Order 4. Another example, if I just have x squared plus x minus 3, we would have an order or a power of 2. And that's it for order and power. It just means what's the biggest power that a variable is raised to in your problem. So I guess one helpful example to look at related to this would be, what if you have x plus 4 to the 6th? Is this an order 6 function? And the answer is no, because this is just a number. 4 to the 6th is a big number. It's like 4096, but it's still just a number, so this would be an order 1. Because it's x, its variable is only raised to a 1 power, so this has no impact. This is just a number and isn't relevant to our question. I wonder if I'm wrong with this. I'm not going to check it, though. All right. Next piece. Then we added and subtracted polynomials. That was kind of our beginning piece last unit. So we took stuff like x squared plus 4x minus 3, and then we like added a parenthesis like negative 2x squared minus 4x plus 7. And one of the nice parts about this is if you have plus in between two parentheses, it's like the parentheses aren't even there. You can just do x squared minus 2x squared and get a negative x squared. You can do 4x minus 4x and get nothing. And you can do negative 3 plus 7 and get positive 4. Please notice what I did there. I could only add together the terms with the same number, the same power, the same order in their exponent. And so I added together my x squareds first, then I added together my x terms, and then I added together my numbers. If you're adding together numbers and x terms, or x to the power 2's and x's, you're going to get horribly wrong answers and be very sad. So make sure you are careful to only add together things with the same number of x's. And just one more warning, this is the final answer here. If you do x squared plus x squared and you get x to the fourth, what you've done is not addition. That's x squared times x squared. When we multiply things with the same base, we add their exponents from our exponential unit. If we do x squared plus x squared, what we should get is 2x squared, because there are two x squareds. When you add things together, you get, 1 plus 1 is 2. And so that is logically consistent with our math. All right, now let's do subtraction real quick. So in subtraction, if I have something similar to what I had in the previous question, I'm going to have this in my first parenthesis, and I'm going to have, let's do negative 2x squared plus 4 in my second parenthesis. One of the safest things to do, and that avoids a lot of the errors people make, is to distribute the negative to both of the things in the second, because then you can just add everything together. So my first term I can rewrite, because the parentheses aren't doing anything. But then I distribute the negative to both of these terms, and I get plus 2x squared and negative 4. And now I can combine all the like terms just by adding, so it becomes like the previous question I did. X squared plus 2x squared is 3x squared plus 3x, and negative 4 minus 4 is negative 8. All right, that's addition and subtraction. Now let's move on to multiplication. So in multiplication, we just took basic things like x plus 2 and 3x minus 1, and we multiplied these guys together. So we turned two binomials that are multiplied together, both of these are binomials, into a trinomial. And the way we did this was by using our box. And we said put x plus 2 on one side, we put 3x minus 1 on the other side, and we filled in the parts like a Punnett square. 3x squared, 6x, negative x, negative 2, and we added together all the things. 3x squared, these add together and give us a positive 5x, and we get minus 2. Sweet. One down. We also had other cases like x plus 4 squared, where you also needed to use something like this, because x plus 4 squared is x plus 4 times x plus 4. So while it's tempting to kill a puppy and get x squared plus 16, that's wrong, and we know it if we do our multiplication. X plus 4 times x plus 4 is x squared, a 4x, and a 16, which gives us x squared plus 8x plus 16. And so that middle piece is the really important part. I can tell that you made a mistake, like the killing puppy mistake on my board, if you don't get that middle term when you square. If you want to get like no middle term, remember it takes a pretty specific circumstance, and that's, our boy, the difference of squares. If I have x plus 4 times x minus 4, and I multiply these guys, x plus 4, x minus 4. Now x times x is x squared, 4 times x is 4x, x times negative 4 is negative 4x, and negative 4 times 4 is negative 16. And now our middle terms, we have one that's positive, one that's negative, so those eliminate, and all we get is x squared minus 16. So if you want no middle term, you need to have plus and minus of the same thing in your two binomials. All right, now let's get to factoring, which is the real crux of what we did last unit. The first type of factoring we did was Gcf factoring. So In GCF factoring, the first way we did it was when you had something pretty simple like 4x minus 20. And you just said what is common to both 4x and 20, and what is common is a 4. And you put the remaining stuff at the end, in a parentheses at the end. If you are struggling with figuring out what goes inside the parentheses or don't remember all you do is you say, okay, 4 goes into both of these, you put a 4 on the outside. You start your parenthesis, and then what you put inside is just 4x divided by 4, which is x, and negative 20 divided by 4, which is negative 5. And that gets us there. Now, we did more complicated GCF problems, like what if you have 4x squared plus 7x? What's common to both terms? Well, no number goes into both 4 and 7 besides 1. So what's common is actually that they both have an x. So we take out an x. If we take out an x, we get 4x for the first term, and we get 7 for the second term. And we're done. That's our GCF factoring. We can throw a little bit more into this. What if we have something like 7x cubed plus 14x squared? What goes into both 7 and 14 is 7. What goes into x cubed and x squared is actually an x squared, so I got to take out 2 x's because that's the minimum number in both of my terms. And what I'm left with in the first term is x. What I'm left with in the second term is a 2. And that's it. All right, so that's GCF factoring. Now, our last kind of factoring that I'm going to do today is the kind where a equals 1. Many of you were confused by this when we reviewed it like a week ago in my class. When I say a equals 1, what I mean is the number in front of x squared is always 1 in these. That makes it a lot easier to do these. The kind with a number in front of x squared are the kind we have to do the more convoluted way. It's what we're going to do in the next video, so come Wednesday we're going to be messing with those kinds of questions. But in these kinds of questions, we're going to start off with our first example, which is x squared plus 7x plus 12. Okay, so our only game here is we always want to multiply to a times c, but in the kind when the number in front of x squared is 1, it's just we need to multiply to the last number. And we need to add to 7. So the game we play here is we think of all the multiples of 12. So 1 and 12, 2 and 6, 3 and 4. And we say which one of these add to 7, and sure enough, 3 and 4 do. And yeah, that's basically the end. It's x plus 3 and x plus 4. Now, you can verify these answers all the time by always dumping these into a box. If you multiply these out, you should get back to your original answer. And sure enough, if we do this, x squared, 3x, 4x, and 12, we get a 7x as our middle term, and that gets us back to where we started. So let's go through 3 more of these. First one, x squared minus 4x minus 12. So in this one, we want to multiply to negative 12, and we want to add to negative 4. So I list out the things that multiply to negative 12. So negative 12 and 1, negative 6 and 2. Well, I could keep going, but I think I found it. Those add to negative 4. And the snazzy part about this is we can dump straight to the answer. X minus 6, x plus 2. Now, if you learned the FOIL way or the distribution way, you may remember that you can just check your answer by looking at these. Negative 6 times x plus 2x actually gives you a negative 4x, and so you can check your answer really quickly that way, or again, you can always dump this back into the box and check your answer this way. And sure enough, if we check our answer this way, we get the correct answer, getting a negative 4x for our middle term. All right, two more examples to go. Oh, it looks like I lied. Looks like there's 3 more examples to go. Haha. Okay, x squared minus 6x plus 5 is our next one. So I need to think of things that multiply to 5, but they need to add to negative 6, so I can instantly tell that I need both of my factors to be negative. I can't use 1 and 5, that would be garbage, because those add to 6. So how about I try negative 1 and negative... Oh, that works. Okay, cool. So this is x minus 1 and x minus 5. Okay, our next example is x squared minus 36. And if you remember from where I was talking a little earlier when we were multiplying, if we have no middle term, we know something right away. We know it's x plus something and x minus something. But these somethings need to be the same thing. And so the easy way to tell this is, what is the square root of 36? And it's 6. So it's x plus 6 and x minus 6. That give us x squared minus 36. Cool. That's it for that. Next one. 2x squared minus 8. This one I put in here because we have a couple steps here. The first step is, you may notice our a is not 1. We have a number in front of x squared, which normally makes us pretty sad, but here 2 goes into both of these things. So I can pull out my greatest common factor first. And I get 2 times x squared minus 4. Now I can factor the remaining piece, this x squared minus 4, using my difference of squares. There's no middle term. So I square root 4 and I get 2. And then I just do x plus 2 and x minus 2. I need to be careful that I make sure I leave my 2 on the outside here, but that's it. That's all there is to it. Difference of squares makes life a little easier. I hope this review of factoring was helpful, and I will talk to you again on Wednesday to talk about when a is not equal to 1 and more complicated cases. All right, thank you. Bye-bye.